analyzing their antenna based on experimental results. Then I found there is something missing. So they don't have their theory. Then we started working on the theory. It is nothing very different or special. It was inverted microstrip patch. So accurate estimation of fringing field is a very hard task. We worked on that and it was published. Then I'm telling out my first experience after this publication was over. We gave one complete theory, and within a couple of months, I remember 2 to 3 months, I received one email from CRC Canada, Communication Research Center. It is in Ottawa, Canada. They wrote to me that we have read your paper and we want to work on that, but we need the code. HFSS-less world. So designing was very difficult, characterization was very difficult at that time. We sent our whole code. Their second mail, they told that your code is not easy to handle because it was written in Fortran 77 that time, and they are not used to Fortran 77. So you better design one antenna for us. That time I did not realize why they were asking for 1.9 gigahertz. Now you can understand the purpose of 1.9 gigahertz. We designed it, complete design, including its feed location, the superstrate, substrate, the whole structure was defined, single element. And it was a big suspense for us. That is the first challenge. Because when you are working or developing some of your structure, you do your own design and you do your measurement. So you can figure it out, what's happening. So for me, it is just giving the design to them. And I had no idea about the fabrication and type of their work culture at that time. But later on, I found it. If you go to any US lab, Canadian lab, and after your experiment is done, when it will be given to you, you will feel that it is from factory. In our case, there is some sellotape, there is some thread, kind of supporting structure will be measured, and then we are happy with this. They don't rely on that. It has to be 200% perfect, robust, mechanically, electrically, everything tested. I did not know that. Then it would have been more serious to me. I was waiting, but what happened? I have given for 1.9. If I find it is resonating at 2.5, then it will be very difficult for me. CRC sent the results after a few days. I still remember the exciting moment. That was the result. They did the fabrication experiment, and it operated at 1.87. So that gave us the second level of confidence, and that is very important. That the main theme of my talk is you will have to face challenges at every step. You will have to accept the challenge, and you will have to succeed too. I added one slide. It is mainly for the new antenna engineers. That antenna design is fine, but feed design is very complicated and critical. The reason is clear to you. Just I am telling you that very fundamental theory what is taught in our undergraduate course. Here you know the blue part is the dipole, that is metal, and red part is the feed. Actually, we are concerned with the blue part, so it is separated. And when we deal the matching part, we consider its equivalent circuit. Radiation resistance. But you please don't take this term, radiation resistance, in a very serious sense. Because radiation resistance, though it is taught in a very serious way in our undergraduate courses, it has the existence or meaning only in case of dipole and monopole. The other antennas, in practice, what we are working on, we don't care the radiation resistance. What is significant? Its equivalent term is, or more engineering friendly term is, feed point impedance. By chance or by nature, the feed point impedance and radiation resistance, they are close to each other, particularly in these two structures. What is the difference? You cannot change your radiation resistance based on your feed location. It is fixed. But feed point impedance, that is ZE, it is the function of the location of the antenna and the distribution of electric field and currents. So from engineering perspective, always you to consider feed point impedance and forget about the radiation resistance or antenna resistance. Second experience, I am telling you, I was working that time as a visiting researcher in Canada, Kingston. I received one email. It was in 2005. Before the winter, like October, November, the one email came. The actual email came to my boss. He forwarded it to me. This company was building some base station antennas, that is wireless antennas. They sent a set of requirements, and if I tell that their numerical values, it will be boring to you. So I am trying to give one beautiful example so you enjoy. What's that demand? I am telling you, when you are working with industry, probably you are more familiar with this. One is the very raw type of information first, and when you sign the NDA, then you will get the finer data. So based on this raw type of information I am telling you, suppose you have a bucket of this size. So their demand, it has to be transformed to sleek, small height. Fine, you can do it. But at the same time, they demand that you need more water and more weight. That is synonymous to larger bandwidth, larger gain, but the